Hello, my dear students. Let us continue with the classification of the dam. Last class, I discussed about classification based on use. Today, let us discuss about classification according to hydraulic design. There are two types, overflow dam and non-overflow dam. Let us first discuss about overflow dam. An overflow dam is the one which is designed to carry surplus discharge, including floods, over its crest. Its crest level is kept lower than the top of the other portion of the dam since water glides over its downstream face. It should be made of such a material which is not easily eroded by flowing water. Such dams are generally made of concrete or masonry. An overflow dam is commonly known as spillway. Let us discuss about the next type, that is a non-overflow dam. A non-overflow dam is the one in which the top of the dam is kept at a higher elevation than the maximum expected high flood level. Water is not permitted to overtop the dam. Hence, a non-overflow dam may be constructed of wide variety of materials such as earth, rockfill, masonry, concrete, etc. For example, gravity dam, earthen dam and rockfill dam. So this is about overflow and non-overflow dam. Let us discuss about the third type, that is the classification according to material. According to the material used in the dam, it may be classified as rigid dams and non-rigid dams. Rigid dams are those which are constructed of rigid materials such as masonry, concrete, steel or timber. These dams deflect and deform very little when subjected to water pressure and other forces. For example, solid masonry or concrete gravity dam, arched masonry or concrete dam, concrete buttress dam, steel dam, timber dam. Next is non-rigid dams. Non-rigid dams are those which are constructed of non-rigid materials such as earth or rockfill. There are relatively large settlements and deformations in a non-rigid dam. For example, earth dam, rockfill dam, combined earth and rockfill dam. So this is about rigid and non-rigid dams. Now let us discuss in detail of gravity dam and buttress dam, arch dam, rockfill dam and earth dam. So let us see first gravity dam. A gravity dam is the one in which the external forces such as water pressure, wave pressure, silt pressure, uplift pressure, etc. are resisted by the weight of the dam itself. Thus, the forces disturbing the stability of the dam are resisted by the gravity forces of the mass of the dam. A gravity dam may be constructed either of masonry or of concrete. Masonry gravity dams are nowadays constructed of only small heights. All major and important gravity dams are now constructed of concrete only. A gravity dam may be either straight or curved in plan. As the entire load is transmitted on the small area foundation, such dams are constructed where rocks are competent and stable. These dams are heavy and massive wall-like structures of concrete in which the whole weight acts vertically downwards. Example, Bakra Dam is the highest concrete gravity dam. And also this Kyares Dam in Mysore, that is also a gravity dam. It is a very famous that is located in Mandya district near Mysore in Karnataka state. Sir M. Vishweswaraya, he built that dam, KRS. It's very famous dam. The construction of this project was started in the year 1924 and was completed in 1932. Now let us discuss some advantages of this gravity dam. As compared to earth and rock-filled dams, gravity dams have the following advantages. That is, gravity dams are relatively more strong and stable than the earth dams. They are particularly suited across gorges, having very steep side slopes where earth dam, if constructed, might slip. Gravity dams are well adapted for use as an overflow spillway crest. Earth dams cannot be used as overflow dams. Due to this, gravity overflow dam is often used for the spillway feature of earth and rockfill dams. Gravity dams can be constructed of any height provided suitable foundations are available to bear the stresses. The height of an earth dam is usually limited by the stability of its slopes, requiring a very wide base width. Highest dams in the world are made of gravity dams only. Gravity dam is specially suited to such areas where there is likelihood of very heavy downpour. The slopes of the earth dam might get washed away in such a situation. A gravity dam requires the least maintenance. The failure of a gravity dam, if any, is not sudden. It gives enough warning time before the area to downstream side is flooded due to the damage to the gravity dams. On the contrary, an earth dam generally fails suddenly. A gravity dam is cheaper in the long run since it is more permanent than any other type. Thus, benefit cost ratio of such a dam is always higher. There are some disadvantages also, like gravity dams can be constructed only on sound rock foundations. They are unsuitable on weak foundations or on permeable foundations on which earth dams can be constructed with suitable foundation treatment. And also, the initial cost of a gravity dam is always higher than an earth dam. Hence, where funds are limited and where suitable materials are available for the construction of an earth dam, the earth dam may be preferred. If mechanized plants such as manufacturing and transporting mass concrete, curing of concrete, etc. are not available, a gravity dam may take more time to construct. Gravity dams require skilled labor or mechanized plants for its construction. It is very difficult to allow subsequent rise in the height of a gravity dam unless specific provisions have been made in the initial design. These are some of the advantages and disadvantages of gravity dams. Now let us discuss about the next type of dam, that is arch dam. An arch dam is a dam curved in plan and carries at major part of its water load horizontally to the abutments by arch action. This part of water load depends primarily upon the amount of curvature. The balance of the water load is transferred to the foundation by cantilever action. The thrust developed by the water load carried by the arch action essentially requires strong side walls of the canyon to resist the arch forces. The weight of the arch dam is not counted on to assist materially in, in the resistance of external lows. For this reason, uplift on the base is not an important design factor. These types of dams are constructed of concrete or masonry dams which are curved or convex upstream in plan. This shape helps to transmit the major part of the water load to the abutment. Arch dams are built across narrow, deep river gorges, but now in recent years they have been considered even for little wider valleys. These are some of the pictures of arch dam. The advantages of arch dams includes arch dams are particularly adapted to the gorges where the length is small in proportion to the height. For a given height, the section of an arch dam is much lesser than a corresponding gravity dam. Hence, an arch dam requires less material and is therefore cheaper. Next point, because of much less base width, the problem of uplift pressure are minor in case of arch dam. And also, since only a small part of water load is transferred to the foundation by cantilever action, an arch dam can be constructed in moderate foundations where gravity dam requiring sound foundation rock may be unsuitable. There are some disadvantages it requires skilled labor and sophisticated form work. The design of an arch dam is also quite specialized, and also the speed of construction is normally slow. It requires very strong abutments of solid rock capable of resisting arch thrust. Hence, it is not suitable in the locations where strong abutments are not available. Unfortunately, only few sites are suitable for this type of dam. Let us discuss about Buttress Dam. A buttress dam consists of a number of buttresses or piers dividing the space to be dammed into a number of spans. To hold up water and retain the water between these buttresses, panels are constructed of horizontal arches or flat slabs. When the panels consist of arches, it is known as multiple arches type buttress dam. If the panels consist of flat slab, it is known as deck type buttress dam. This type of structure can be considered even if the foundation rocks are little weaker. Let us discuss some of the advantages of buttress dam. A buttress dam is less massive than a gravity dam. Hence, the foundation pressures are less in the case of buttress dam, and it can be constructed even on weak foundations on which the gravity dam cannot be supported. The water load acts normal to the inclined deck, hence the vertical component of the water load stabilizes the dam against both overturning and sliding, and the buttress dam possesses a factor of safety much greater than that obtained in a gravity dam. In the case of gravity dam, the height of the dam can rise only by the provision of crest shutter at overflow section. However, in the case of buttress dam, further rising of the height is possible and convenient by extending buttress and slab. Consequently, buttress dams are used where a future increase in reservoir capacity is contemplated. And also powerhouses and water treatment plants can be housed in between buttresses, thus saving some cost of construction. The amount of concrete used in buttress dam is about half to one third of the concrete used in gravity dam of the same height. However, the cost of construction of a buttress dam is not low in that ratio because of the increased cost of reinforcement and of form work. Access is possible to the back of the upstream face and to foundation between buttresses for periodic inspection and for subsequent grouting and drilling of pressure relief holes if required. So, the most efficient use of strength of concrete lead to the economy in quantity required, though the financial economy will not necessarily be directly proportional to the quantity of concrete saved. So these are some of the advantages of buttress dam. Let us discuss some of the disadvantages. Skilled labor requirements and the shuttering concrete ratio are greater than for solid dams. This may lead to higher limit rates and so offset some of the saving due to reduction in the quantity of concrete. And also deterioration of upstream concrete surface has serious effects on buttress dams with very thin concrete face. And also buttress dam is more susceptible to willful damage. Okay, so these are the some of the disadvantages of buttress dam. Thank you.